Hey, welcome back. Thanks for checking in. We are beginning Unit 5 now, and Unit 5 is called Linear Systems. So basically, we're going to take a lot of the information you learned in Unit 4 when we were working with linear equations, and we're going to continue working with them, but now we're going to be looking at two equations at the same time. And while it's not a very long unit, Unit 5 isn't really, it's only like 3 lessons. There's actually a lot that has to be done within those 3 lessons. So today's learning target is that you're going to graph systems of linear equations. So if you remember graphing a linear equation, right, where you plot a point and drive the slope, remember graphing lines? We're going to be doing that today, but you're going to be doing this for 2 lines, or 2 equations, which become 2 lines, on the exact same graph. And then you get to analyze the graph. You get to kind of analyze the lines and see what happens. So what is a system of equations? Well, that is when you are considering 2 or more equations that have the same variables. So the variables are going to be x and y. And when it says 2 or more, don't get too worked up about that, because in 8th grade we only consider 2 equations. I don't push you into 3 equations or 4 equations. It's just a system of 2 equations. So there are 3 things that can happen when you're working with systems. One thing that can happen is that the system has what's called one solution. That means when you graph your lines, maybe one line goes like this, the other line goes like that, and where they crisscross, right here, that is called the solution for that system. Because at that point, whatever the x and y value is right there, that would solve both equations. So if you graph your lines today and you notice that they cross at one point, that's called one solution. And then they want you to name that ordered pair. They want you to name the x and y. Another thing that can happen when you graph these lines is that maybe one of the lines goes like this, and you graph your next line and it looks like this. And they don't ever cross each other. They are parallel lines. That is called no solution, because there is no x and y value on the blue line that will also work for the green line. So because they never cross each other, that's called no solution. And then imagine this. This is the third thing that could happen. Maybe your first line goes like this, and you graph your second line, and you notice that, hey, look what happened. It's the exact same line. They're like completely and totally overlapping. That's called infinite solutions, because what you're saying is that every point on the blue line, every ordered pair for the blue line, is also an ordered pair for the green line. So every x and y value will work for both equations. So again, it's one solution, and then you name the ordered pair, or it's no solutions for parallel lines, or it's infinite solutions because it ends up being the exact same line. So, oops, sorry about that. Let's get graphing. Let's see if you remember how to graph linear equations. Y equals mx plus b. So it says solve the system of equations by graphing. Here's our first equation right here. Y equals x. Now, we're used to seeing this, right? Y equals mx plus b. And that's kind of the goal today. The goal is to get that format, because that's what we like to graph from. So if the first equation says y equals x, you're like, wait a minute, there's a bunch of stuff missing. Well, I kind of filled it in for you. In front of the x is really a 1 over 1, right? Isn't that really a 1x? And then as far as the plus or minus b, since there's nothing out here, it's really a 0. So I took the original equation of y equals x, and I modified it so that you could see the actual numbers that you're going to be working with. Now, let's remember, y equals mx plus b. What do we plot first? You plot your y-intercept. The y-intercept is 0. So I came down to my graph. I put a dot right here where the 0 is. That's my starting point. And now I have to drive my slope. My slope is 1 over 1. Remember that when your slope is 1 over 1, it's up 1, right 1. So once I plotted my y-intercept, I went up 1, right 1, up 1, right 1, up 1, right 1, or I could go down and left or down and left. But anyways, you can see that I connected the dots and I have my nice red line. I'll make this a little bit bigger so you can kind of see. Okay? Now, if this was unit 4, you'd be done. This isn't unit 4, this is unit 5, and it's a system, which means now we're going to do the exact same thing for another equation. You're going to graph it on the same coordinate plane, and we're going to see what happens. So we go to the blue equation, y equals negative 3x plus 4. All right, so I know my slope is negative 3 over 1, which means down 3, right 1, and I know that my intercept is positive 4. So I go up here to positive 4, and I put a big dot, and from there, I go down 3, right 1, down 3, right 1, connect my dots, and I drew that blue line. Now you look at your graph and you go, oh, look what happens with these two lines. These two lines intersect each other at one point, and it's right here. So I circled it. That is the solution to this system. Now you're supposed to name that ordered pair, and I did. It's right here. It's 1, 1. So when x is 1 and y is 1, both equations will work. That's the whole point of what we're doing here. We're trying to find the ordered pair, or the x and y value, that will work for both equations. And in this case, if x is 1 and y is 1, the math will work. If you were to go back to your original equation, I'll erase some of this stuff. If you put a 1 here and a 1 here, does it work? Yes. If you were to go over here and put a 1 here and a 1 here and do the math, negative 3 times 1 plus 4 is 1. 1 equals 1. It works. That's what we mean when we say the solution to the system. Okay? So it's really just graphing, and then you kind of look to see what happens with your graphs. Here we go. Let's do another one. Y equals x plus 2. So this is really 1 over 1 x plus 2. So this is your y-intercept. You plot that point. There it is. My slope is 1 over 1, which means up 1, right 1. I like slopes of 1, right, because it just goes kind of diagonal through all these corners. Okay? It's definitely beneficial to make your line as long as possible. If you don't make your lines long enough, you may not get to see if they cross or not. So try to make your lines nice and long. All right, let's do the other equation. Y equals negative 2x minus 4. Here's the slope, negative 2 over 1, intercept of negative 4. Oh boy, I got to go down to negative 4. 1, 2, 3, 4, way down here. And my slope was what? Down 2, right 1. Down 2, right 1. See, I'm out of room. So I need to go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. I connect all my blue dots. And what happens in this system? Do you see? It has one solution, and it's right there. So now you have to name that ordered pair. Where is that? Well, from the origin, it's left 2, so that's a negative 2. And then you don't go up or down, so it's a 0. That's the answer. There's one solution to this system, and it is the ordered pair of negative 2, 0. All right, let's keep going. Y equals negative x, so that's really negative 1 over 1 x, and the intercept is plus 1. So plus 1, there's my y-intercept, and down 1, right 1. Remember, nice, long lines, because you just don't know where that other line is going to fall. All right? Next equation, y equals negative x minus 3. Again, that's negative 1 over 1, really, right there. And an intercept of negative 3. Where's negative 3? Right here. Slope of negative 1 over 1. Remember, this is the easy one. It just goes right through these diagonal corners. Well, What do you think's happening here? Parallel lines, right? And when the lines are parallel, they don't cross at any point. This is called no solution. Because there is not one ordered pair on the red line that will also work for the blue line. So there is no x and y that will solve the red equation that will also solve the blue equation. No solution. Okay, we have one more. Here we go. Y equals 1/2 x minus 1. I plot my intercept, my y-intercept of -1. There it is. And my slope is 1/2. So up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2. Right? Draw my line. Right? So I hope you got good at graphing in Unit 4 because, oh, man, would you look at that equation? It's not in the right order. Remember, we want y equals mx plus b. Gotta shift some things around here. I need to move that x term over. So you do that by minus x, right? Remember, there's a 1 there. Now I look back at the y. He doesn't want to be multiplied by a -2. So he gets divided by -2. He gets divided by -2. He gets divided by -2. Y equals 1/2 x minus 1. Right? That's also something that we worked on in Unit 4. So let's plot our y-intercept, which is -1. And my slope is 1/2. Up 1 over 2, up 1 over 2. Oh my gosh, it's the same y-intercept and it's the exact same slope. Which means it's the exact same line. Which means you have infinite solutions. Which, I know you kids love to make that infinity symbol. You could do that. Infinite solutions. I'm running out of room. Apologies on that. Infinite solutions. Every ordered pair that will solve the red equation will also solve the blue equation because it ends up being the exact same slope and the exact same y-intercept. So we're going to spend quite a few days working on this graphing concept. It's called solving by graphing. And probably like 3 or 4 days. It's going to take a while. I want you to get really, really good at this, all right? So I'll see you in class. Thanks for watching.